Hi everyone, welcome back to Lifey Technologies YouTube channel and thank you for watching. Just a kind reminder that if you are watching this series and other videos on our channel and you are yet to subscribe, please hit that subscribe button to support our channel and stay tuned for more upcoming videos. So this is a continuation of our IPRAN training series. And remember that we have discussed various principles of IPRAN design and implementation for service provider networks. We discussed the general architecture of IPRAN network from the CSGs, ASGs, RSG, and even the radio access equipment and the controllers for different access technologies, 2G, 3G, 4G, and 5G. We have also discussed the different topology setup for IPRAN, including the ring, chain, and star topology. And we also discussed how to design and deploy IGP on IPRAN network. Remember, we have discussed in detail how to design ISIS for IPRAN network, the aggregation, the access, and how to perform route import between the different processes. And we have also discussed BGP and MPLS design for IPRAN network, both inter-AS and intra-AS BGP design for IPRAN network. And in our last few episodes, we have discussed how to design mobile services for service provider networks, the SRAN solution, how to do IP address and VLAN design. So all those are preparations for deploying services on the IPRAN network. So remember, the main objective of setting up the network is to be able to carry some services. So in this episode, we'll be discussing how to configure mobile services on IPRAN network. So if you haven't watched the previous videos, you can check them on our channel for better understanding, just to have a good overview of the general architecture of IPRAN network and the protocol designed for IGP, BGP, MPLS, and even LDP. So we have discussed all these protocols and we have demonstrated how to configure them. But as I've mentioned, you need to do all those preparations before you can now deploy services on the network. So we have configured ISIS for reachability and connectivity. We have configured BGP and MPLS and LDP so that we are able to deploy these mobile services using VPNs. So this is the topology setup. You can see that we have the BTS connecting to the CSG, and the CSG connects to the ASG. The ASG connects to the RSG, and RSG connect to the VPC, the virtual private cloud that will be hosting the controllers for different access technologies. So this is just a simple topology to demonstrate how to configure the mobile services, but the configuration steps are the same, whether you have 100 routers, 100 CSGs, SGs, or RSGs. The concept is the same. You just need to do proper planning for the ISIS, BGP, MPLS, and even for the VRFs, the VPNs, the IP addresses, and the VLANs. So these are things that you need to prepare before you start configuring services on the IPRAN network. So these are the details. You can see from the table we have the service. So we are configuring 7 services. We have O&M, we have 2G, we have 3G, we have MME for 4G signaling, we have user for 4G data, we have 5G signaling and 5G user. So these are the VRFs or the VPN that we'll be configuring on our network so that we are able to transport all these services on our transmission network. We have the route distinguisher for different VRFs. We have the route targets that will be used to control route import and export. And then we have VLANs planned for each and every service. We have subnets, the network or the IP address subnet that will be configuring, and the gateway assigned to be configured on the BTS. So this is preparation that you need to do prior to configuring services to ensure that you don't have duplicates. You should not be having duplicate VLANs for the same service that is to be configured on the same router. You should not be having same IP addresses assigned to the same service. So you need to do proper planning before you start deploying the services. So if you haven't watched the previous videos, kindly check them out for a better understanding of this detailed implementation for IGP, ISIS, and even the general architecture and how to do the planning. So for this lab, we'll be following these steps. The first step is to do basic configuration. We need to configure site name. Remember, a site will always have a name, a site will have an ID. So you need to do proper planning for the site names and the site IDs. And then you can configure this site name and site ID when you are doing the deployment. And then in step 1, we also have to do interface IP configuration. So we'll be configuring interface IPs for the interconnected interfaces and also the loopback IPs that we'll be using for BGP configuration and even for MPLS and LDP. So once we have done IP address and system name configuration, step 2 will be to configure access and aggregation IGP process on CSG, ASG, and RSG. So you can see that we'll be using different access and aggregation IGP processes. And then step 3 will now to perform route import between access and aggregation IGP processes. So we'll be importing access routes to the aggregation and also importing aggregation routes to the access, just to ensure that we have end-to-end reachability. And once we have done that, we move to the fourth step. We configure MPLS and MPLS LDP. Remember, the IPRAN network is our MPLS cloud or our MPLS backbone. So we need to enable MPLS, configure the LSR ID, and enable MPLS on interfaces. And then step 5 will be configuring the VRFs, the VPN instances on the CSG, SG, and RSG. This is in the same autonomous system. So the configuration for the VPN instances will be the same. So we have O&M VPN, Pubis VPN, IUB, S1MME, S1 user VPN, 5G signaling, and 5G user VPN. And then we have the planned route distinguisher and route targets. So you should pay attention to the route distinguisher and the route targets. Once we have done the VPN instance configuration, the next step will be to configure MP-BGP, multi-protocol BGP VPN, before peering between CSGs and ASGs. So we configure BGP peering session between CSG and ASG, and then ASG and RSG. And then they should be able to exchange service routes. So once we have done that, now we can configure the services on the CSG. Remember, we need to configure the gateway IP addresses on the CSG and also bind the relevant VPN instances. After that, the final stage will be to configure BTS and import service routes to the BGP, and then do final verification for the services. So we check whether we are getting the MAC address and we are able to ping for different services from the CSG to the BTS. So these are the steps that we'll be covering. If you don't understand any of these steps, we have a separate video on our channel. You can check it out on the playlist. You can even check out the playlist for our Huawei Lab simulation that will help you to better understand how to implement these different protocols on Huawei routing devices. So this is the topology setup. We are configuring AS100, so our IPRAN network will be in one AS100, and we have ISIS 10 as our access ISIS and ISIS 100 as our aggregation ISIS. Then we have this router simulating a BTS, and this one will be simulating the virtual private cloud. So we have the CSG, the ASG, and the RSG. So we can now start the configuration. For the configuration, I've mentioned that the first step, we are just doing the basic node configuration. So these are the configuration that we need to do on CSG1. We need to configure the sysname and assign IP address on the interface. It's also a good practice to assign the description, configure the description for the interfaces. So these are the configuration I will do on CSG1. I will copy, log into CSG1. I'm using a CX just so that I'm able to configure statistics. Remember, statistics will be used for monitoring. So once I've configured, I will commit. This is CSG1, and then we can move to SG01. On SG01, we need to configure the sysname SG01. If you are in a production network, always there will be a site ID and the site name that is given from the planning team. So you always have to configure the right site ID and the right site name. So we'll configure the two interfaces, 100 that is pointing to CSG01, assign the IP address, and also 101 that is pointing to RSG01, and this is the loopback IP configuration. So I will copy this, log into SG1 system and paste. We do a commit. These are CX, so you always have to commit. And then we now do the configuration for the RSG. RSG, the sysname will be RSG01, and then the interface configurations. So you always have to enter the command system view before you start doing the configuration, then commit. So we have finished step 1 of our configuration, just basic configurations. To verify, you can display, for example, you can display IP interface brief. You can see that we have IP addresses assigned on Ethernet 100, and then the loopback IP is also configured. We can do the same for SG1. Display IP interface brief. You can see the interface IP configuration on RSG1. We can do the same, display IP interface brief. So you have the IP addresses assigned for the point-to-point and also the loopback interface. So once we have done that, we can move to the next stage of configuration. We need to configure access and aggregation IGP processes. So we are using ISIS, so you need to configure ISIS process 10 on CSG. We are configuring all routers in level 2. Core style will be set to wide. Remember, we can also set it to narrow. The network entity is generated from loopback 0. And then we set the IS name for easy identification of this ISIS session. So we can configure the ISIS and verify the status. So on CSG1, I will copy this, log into CSG1, paste, commit. There is an issue with the network entity. There is space on the network entity. There is some space, so I will copy it and configure ISIS10. Display this. We don't have network entity configured, so I can just copy this. So we need to clear this space. There is some space here. So I can display this. We need to commit. This is a CX. Display this. So we have it configured. And then we can now configure SG01. So SG01, we also need to ensure that we don't have space. So we have ISIS 100 for the aggregation, the network entity, and the ISIS level is still ISIS level 2. You can always give a description for the ISIS process. And we have ISIS 10, the access ISIS process. We have given it a description of access ISIS. It's in IS level 2. And then we're giving the name of SG01. So I can copy this and do editing for the network entity so that we don't have to reconfigure. So this is SG01. Copy this. Can do editing from here. Control V and clear the space. So I will copy this and configure on SG01. Paste, commit. Then finally we need to configure RSG01. So for RSG01, we are configuring only the aggregation ISIS process 100. We give it a description. The IS level is still level 2. The core style is set to wide, and then IS name is set to RSG01. We enable SIS on the interface facing the SG, and also we enable SIS on the loopback 0 interface. So I will copy this just to avoid having the space again, and I can edit it from here. So I will delete this space, copy, go to RSG01, and we paste and do a commit. So from SG01 we can check the SIS status, display SIS peer. We have one SIS peering session. CSG1, display SIS peer. We have one peering SIS session. On RSG1, display SIS peer. We don't have an SIS, display SIS interface. To verify that we have the right interface configured. So on RSG1 we have interface 100. Let's verify it. Display current configuration, interface Ethernet 1/0/0. So we have an IP address of 10.250.250.2. We can ping the interface IP 10.251.250.250.3. So this is where the problem is. We need to check on SG01, display SIS interface, it only on Ethernet 101. Let's see the configuration, display current configuration, interface Ethernet 1/0/0. We have SIS enabled, but we have a wrong interface IP configured on Ethernet 1/0. So we can check the interface 1/0 is facing this one. We need the interface 101. So on this node we can 101. We have IP address of 101. Let's try to ping 10. Oh, I see the problem. So this is the power of troubleshooting. You always have to be able to troubleshoot the basic problems, especially when you have misconfigured the IP addresses. So when you check on our topology, between SG2, SG1 and RSG1 we have an IP of 10.250.250.2, but I've configured 251. So you always have to be able to troubleshoot these problems on your own and identify the issue that you are facing when you are doing configuration on the routers. So I will assign IP address of 10.251.10.250.250.3. mask is 31. So display this, display SIS peer, display SIS peer again. I need to commit, display SIS peer. So we have one SIS in process 10 and another SIS, the aggregation SIS in process 100 is coming up. So we can verify that on SG1, if I display IP routing table, we are able to get the routes. As you can see, we are getting routes in different SIS processes. But of course, we cannot be able to reach from SG1, given that we haven't done any route importation. We are not able to ping the loopback IP of, let me try to see, 10.251.250.2. So we are able to ping from SG1, but on CSG, if we try to ping the loopback IP of the aggregation node, the ASG, we should not be able to. 251.250.1. So we are not able to ping because we are not learning the route. We haven't done any route import between the two different SIS processes, the access and aggregation. So if I display IP routing table, you can see that I'm only learning this direct routes. I don't have any other routes coming in from SIS. So that's why we need to do the route import. So on RSG, the same, display SIS peer, display IP routing table, should be having some SIS route, the loopback 0 of SG01, should be able to ping because they are in the same SIS process 251.250.1. We are able to ping from RSG to the ASG, and similarly we should be able to ping from ASG to the RSG. So we can ping 10.251.250.0. So we are able to ping from SG to SG, SG to RSG, and RSG to the ASG. So the next step of our configuration is to do route import between the access and aggregation. Remember, this one we are just doing it on the aggregation, not the ASG. So this one will help us to have connectivity from the ASG to the RSG's loopback. I mean from the ASG to the CSG's loopback, and the CSG will also be able to reach the loopback of the ASG before we do BGP configurations. So we are getting an IP prefix to import loopback of the aggregation node and another IP prefix to import the access to aggregation node. And we are only importing the point-to-point and the loopback IP. And then we configure a route policy, the two route policy. One route policy, import access to aggregation, and another route policy, import aggregation loopbacks. So we import the aggregation loopback from aggregation to the access, and we import the point-to-point and the loopback IP from access to aggregation. So these are the configuration that I need to do on the ASG, and we can verify that we should be able to ping. So on ASG, you can now configure this, commit. So I go back to the CSG, we display the route. You can see that now we are able to get the loopback IP of SG, and we should be able to ping 10.251.250.1. We are able to ping. So that is the stage that we do the route import between the access and aggregation. We are using the IP prefixes to match what we need to import, and then we are using route policies. So it's always a good practice to use route policies and not to import everything from one protocol or one process to the other. So always use the route policy and the IP prefixes. So step 4 is to configure MPLS and LDP on CSG, SG, and RSG. So for MPLS, of course, we need to configure the MPLS LSR ID, and we are using the loopback IP as the LSR ID. And we can now, once we have configured the LSR ID, we can go ahead and configure MPLS and enable MPLS on the interfaces. So these are the configuration that we need to do on CSG. As configure LSR ID, enable MPLS globally, and enable MPLS LDP on the routers. So I log in back to CSG1, I quit, then paste. That is it, commit, display current configuration. You can see that we have MPLS LSR ID configured, we have MPLS and MPLS LDP enabled. So the next stage is to configure SG01. So we also configure LSR ID and the loopback IP, enable MPLS globally, and then MPLS LDP, and configure MPLS on the interfaces in our MPLS backbone. So the two interfaces, one facing the CSG and another one facing the RSG. So I'll do configuration on SG1, I'll quit and paste our MPLS configurations and commit. You always have to commit the CX routers. And finally, we need to do the MPLS configuration on the RSG. So we configure the LSR ID and enable MPLS on the interfaces. So I log into RSG1, we need to do the configuration, I will commit. Then on SG we can display MPLS LDP session. So we have two sessions. On CSG, we should be having display MPLS LDP session. We have one session. On RSG, we also expect to have one directly connected session, display MPLS LDP session. So we have one local LDP session established between the different connected routers. So once we have done that, now we can move to the second stage of configuring VRFs. So step 5, we are configuring VRFs on the CSG, SG, and the RSG. Remember, we have done prior planning for the route targets and the route distinguishers on this table. So you need to properly configure the RDs and the RTs. So these are the configuration. We have different VRFs. The first VRF is O&M VPN. This is for the managing of sites. So we give it a description for site O&M, operation and management. And then we are setting the route distinguishers. So these are the route distinguishers and the route targets. Then we configure the other VRFs. So the configuration for the other VRFs is the same. We are only changing the RD, the route distinguisher, that makes the route unique, and the VPN targets that control the import and export of routes. So I will copy these and apply them on CSG, SG, and RSG. So I've mentioned that the configuration are the same. Remember, these nodes are in the same autonomous system. So I need to copy these, log into the CSG. We'll start with the CSG. So on the CSG, I will configure the route, the VRFs, commit. And then on SG, do the same, commit. On RSG, we need to do the same, commit. So on CSG, I can verify the configuration, display current configuration, VPN instance. You can see these are the VRF that we have configured on this node as per our planned RDs and RTs. Display current configuration, IP VPN instance, configuration VPN instance. You can also display IP VPN instance. You see that we have these VRFs and you have the RDs as per the planning. On CSG, we can do the same, display IP VPN instance. You have these VRFs configured. On RSG, display IP VPN instance. You have these VPNs configured on the RSG. So the next step of configuration is now to configure MP-BGP peering session between CSG and ASG, SG and RSG. So we'll start by configuring the ASG. So on ASG, this is the CSG configuration. This is a typo here. So we need to configure the CSG. On the CSG, we are creating a group. Remember, we have discussed how to implement BGP groups on Huawei routing devices. If you missed that video, you can check it on our Huawei lab simulations. And then we are configuring the router ID and we are connecting using the loopback interface. So that is the main reason we have configured IGP, so that we have reachability information between these different nodes. So these are the configuration, and we are enabling the VPN v4 peering between the nodes. So I will copy this, log into the CSG and paste. Something is missing. Okay, so I will paste it here and remove this hash. I will reconfigure again on the CSG. Yes. commit. Sometimes you need to put in the yes command when you are enabling. So that's why we can just edit it here and enable. So we put yes here and then we can reconfigure. Here 1.1.1 enable yes. So commit, quit. Display current configuration, configuration BGP. You can see that we are missing some commands. We need to unicast. So we need to also put here yes, so that we enable, we undo the peering in IPv4 family. So I will rerun this again. Quit, paste, undo peer enable command. This one takes us back to so sometimes you need to recheck the configurations before you apply. Sometimes you may find errors, but when you understand what you need to do, then it's not a big deal. You can always edit your configuration so that you are able to achieve your objective. Display this. So now it's okay. We have the BGP configurations. So we need to do the same for SG configuration. Remember, on SG we are establishing BGP peering session between the SG and CSG. So we have a group called SG CSG group, and we have a group called SG to RSG group. So we create these two groups for the different peering session towards the SG and the RSG. So I will copy these configurations and do the necessary editing so that it doesn't report errors. So for the peering session, I need to yes. Then for IPv4, we need to do the same. We need to enable. And this one we also need to enable. So I will copy this configuration and try to apply our SG. See if it reports any errors. So we are okay. Commit, display current configuration, configuration BGP to verify. So we are okay. And finally, we need to configure the RSG. I will configure the RSGs. We also have to make so on the CSG, on the RSG, I will recheck the configuration again where it's reporting errors. So I need to remove the hash. Remember, hash takes us back to the previous level, the configuration hierarchy level. So that's why many times you see it reporting errors. So I will paste again and do a commit, quit, display BGP VPN v4 all peer. So it's still idle, is establishing display BGP VPN v4 all peer. So between the CSG and the ASG is already established. On the ASG, we can verify again, display BGP VPN v4 all peer. So we are still pending with one session between the ASG and the RSG. We give it some time. On the RSG, we can display BGP VPN v4 all peer again. So it's now established. On the ASG, we can run the same command to verify that our peering session is now up. So we have established BGP peering session between the different nodes. And now the next step is to configure services. This is a mistake. We need to configure services on the CSG. So for the service configurations, remember on our previous step 7 is to configure services on the CSGs. So on the service configurations, there are something that we need to pay attention to. The first one is that we always have to bind the VRF before we assign IP address, or else we will have to redo it. So you can see that these are the configurations that on the CSG1, starting with the site 1 O&M VRF, and then we are doing the VLAN.eq, and we are also enabling statistics on that sub-interface so that we are able to monitor the amount of traffic that is traversing through this sub-interface. So it's always good to enable statistics on these interfaces. So these are the configuration. You always have to configure a sub-interface, assign the .eq VLAN, bind the relevant VPN instance for the planned VPN, and then you need to configure the gateway. And the gateway is configured as /29. So these are the configuration that I need. We'll copy it, and then on CSG1, quit and paste. We have a VPN instance that is not configured, does not exist. Display IP VPN instance to verify. So we are having one VRF that is missing. So we need to configure VRF for 5G, or this is 5G data VPN. So we call it 5G user. So we need to configure the, so on this one we have 5G user. On the node again, we can verify the VRF that we have, 5G user VPN. So this should be user. So I will reconfigure everything afresh, just so that what missed can be picked. Display IP interface brief. I'll do a commit. Display ARP all to see if we are able to learn any MAC addresses. So we haven't done the configuration on the BTS end, so we'll not be able to learn any MAC addresses. But you can see that these are the configured IP address and the VRFs bind to the different VRFs. We have these 111.0.0.3. Let me check. Display current configuration interface Ethernet 1/0/1.1003. So you can see that this is missing a VRF assignment. We can check from our configuration 1003 VPN instance S1MME. This one maybe it also missed the command. Let's check. Let's rerun this and see what error it reports. Paste. S1MME VPN does not exist. Display IP VPN instance to verify the VPN. So we have S1MME VPN configured. What is the error here? It's SI. So just a typo. So I will run the command. Interface Ethernet 1/0/1.1003. One slash 0/1.1003. I need to do IP binding, VPN instance, MME, and then I will reassign the IP address. I can copy this and reassign the IP address and commit, so I can display ARP all. We expect all the sub-interfaces will now be having the VRFs. So we have these VRFs configured, the sub-interfaces are also configured. So the final stage of our configuration is now to configure the BTS end. So on the BTS end, we need to do interface configuration, just in normal sub-interface configuration without binding. Remember, that is the CE, so we don't configure VRF on the BTS, so we'll be just configuring the sub interfaces, as you can see, for different technologies, assign the VLANs, and then assign the IP address plan for the BTS. So we'll be using .2 as the BTS IP. So I'll copy these configurations, log into the BTS system, we configure sysname to BTS, then I can configure. I think I'm having a problem with the IP, the interface 101. Let me see the interface that is enabled, that is 00. So an easy way is to just find this. Find and replace. This should not be the interface. Replace with 0/0/0. We replace all. Okay, and then we can copy and paste again on the BTS end. So this one doesn't, this is why I used the CX, because this one doesn't allow us to enable statistics, but on the CX routers, on the ENSP, we can enable statistics. So I've done the configuration. I can display IP interface brief. You have the IP addresses assigned. Let's see on the CSG, we can display ARP all. And see if we are able to ping from this end to the other end. Ping VPN instance O&M VPN 10.90.0.2. You can see that we are able to ping from the CSG to the BTS display ARP all. So once we have initiated the ping, we should be able to get the ARP. So you can see that we are able to learn the MAC address from the BTS end. So for other VRF, it should be the same. If I try to ping VPN instance S1U VPN and then the IP address assigned S1 user, it's 1090.4.2. So we are able to ping. I can display ARP all. I'm able to learn the MAC address from S1 user. So this one verify that our service configuration is okay. And the final stage that we need to do is to import the routes from the subnets, the networks from the BTS. So we need to import the direct routes. Normally we import direct routes into BGP, and you can see that we are doing it under the VRFs. So we are importing the direct routes into BGP under the VRF. So if you have a sub-interface configured or bind with this VRF and it's directly connected on the router, it will be imported into BGP in the relevant VRFs. We can also have static route configured. We can also import the static routes. So here you'll be copying these. Because if we log into the CSG again and display BGP VPN v4 all routing table, we don't get any routes. Remember, BGP doesn't calculate routes, so we need to import the routes to BGP. So I can paste these. Let me see what I've missed. We don't need the hash. Hash makes us to go back to the previous hierarchy, so I can remove it. And then I will verify the VRF that we have again on the CSG, so that we avoid the previous error that we have had. Display IPVPN instance SIMME, so it's labeled as SI. So this one I need to change it to, should be S1MME, but it's SI, so I'll just change it. But when you are doing the configuration, you can always edit. So I'll paste this. We have imported the routes, commit. Now if I display BGP VPN v4 all routing table, you can see that we have direct routes imported into BGP, the ones with the relevant VRFs, and the subnets are as per the planning. So it's /29, the direct is 32. So this is how you implement services. This is how you configure services for the mobile services on the service provider network for the IPRAN setup. And remember that when we check on the SG, if I display BGP VPN v4 all routing table, you can see that the routes are being propagated from the ASG to the CSG to the RSG. Let's check, from the CSG to the ASG, display BGP VPN v4 all routing table. You don't have any routes from the ASG to the RSG. So in our next episode, we'll be discussing how route distribution is done on IPRAN. We'll be discussing the HVPN solution, HVPN and HOVPN solution that help us to control how routes are exchanged from the ASG to the CSG, from the ASG to the RSG. Remember, this is there is a split horizon because ASG has learned the routes from another IBGP, so it will not propagate the route to another IBGP peer. So we need to solve this by implementing the HOVPN or HVPN solution on IPRAN network. So this is the lab setup that we have done for the service implementation. Remember, we have discussed all these steps and demonstrated how to configure them. And before, we also have series or episodes discussing how to implement these protocols on IPRAN network and even on Huawei routing devices. So if you haven't watched those videos, just check them on our channel. And if you have enjoyed this session, please hit that like button and leave a comment. You can ask a question, you can reach out for the configurations. If you have any challenges, just leave a comment in our comment section. And if you haven't subscribed yet, just another reminder, please subscribe to our channel and stay tuned for more upcoming videos. So I've mentioned that in our upcoming videos, we'll be discussing HVPN solution, HOVPN solution, the seamless MPLS, and all the other remaining principles of how to implement IPRAN for service provider networks. So thank you for watching again, and please Remember to subscribe to our channel and stay tuned for more upcoming videos. Thank you.